When you hear slope, these are the things that you should think of. Do these look familiar? Rise over run. You've heard that a million times. Rise over run.
Yeah.
That is still here. It is here to stay. That is tried and true. Rise over run. Vertical change over horizontal change. Maybe you didn't hear that one as much, but it's the same thing. Y minus y over x minus x. There's an easier way to write that. What is it? Something with a triangle. Delta y over delta x. Delta just means subtract. That's all it means. Delta y means subtract the y's, and delta x means subtract the x's. So change in y over change in x. Y would be your vertical one, and x would be your horizontal. So all of these mean the same thing. It ties back with slope. All right, I'm going to let you stare at those for a little while and see what positive slope looks like, negative slope, and then what zero and undefined slope looks like. You have those on your notes already.
No, I got it. Thank you.
Sure. Positive. This is really important. I can't just say, oh, positive slope is when it's going up. That would not make sense because you could make all graphs go up, right? Oh, this one's going up, and look, Miss Tan, this one's going up too.
You can tell which way.
Exactly. So positive slope is not just when it's going up. It means as x gets bigger, your graph is going up. As x gets bigger. So when you're headed to the right, if your graph is going up, 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 it's positive. If you're headed to the right, if x is getting bigger, but your graph is going down, 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 then you have a negative slope. So you're always looking to the right. As x gets bigger, what is your graph doing? Up, positive, down, negative. But that's only as x is getting bigger. And then hopefully your teacher last year showed you the little tricks. If it's horizontal, it has zero slope. Well, how do you keep track of zero and undefined? They're easy to get mixed up. Well, you could turn that line into the letter Z, Z for zero. Does that look familiar? And you could turn this one into the letter U. Look at that. U for undefined. I can't turn this one into a Z. I could try as hard as I wanted to, but I could not turn it into a Z unless it was sideways. And I could not turn this one into a U. So this one I can turn into a Z for zero, U for undefined. Okay? All right. Finding the slope. All right, so first of all, there's just the counting method. And we love this method. If I give you a graph, then you can absolutely find the slope of it. Because you just find 2 points, and you count rise, and then you count run, and then you just divide them. So go to your notes where it says, what is the slope of line P? On the next page. What is the slope of line P? What is the slope of line P? So you need to find 2 dots on line P. Find the 2 dots. You see them? Travel up and then travel over. And find out what the slope is. Count how many boxes it takes to rise and how many boxes it takes to run.
Up 2 over 3. Up 2 over 4.
Oh man, we're getting all different answers.
No, it's 2 over 3.
Did you go from point to point?
Yep.
Maybe I have a different graph than you do. No, you're not going. No, you need to go from dot to dot.
So, like what?
What?
But if we were doing like a slope.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. That's 6. Now that might reduce to exactly what you were doing. That's fine. So the rise is 6. The run is 9. But we would never put 6/9 as our answer because that is reducible. So we would go to our calculator. Do this with me. I want to show you something in your calculator. I want you to do 6 divided by 9. And you get a decimal. You're not allowed to put that decimal as your answer. Do you know how to turn that thing into a fraction? Oh, good. Math, enter, enter.
Yes.
all the time, every time, math, enter. Yes, you could have gotten 2/3, but it just makes me nervous because there wasn't a dot there. So what if that was like almost on the line, but it was a little bit off? Then you would have been in trouble. Okay, question.
Not really.
Can you reduce it in your head? Sure. You can always reduce things in your head. That's like saying if I went to my calculator and did 9 minus 7 is 2, and then someone said, could I just do that in my head? Please, definitely do it in your head if you're able to do that. Always. Only use a calculator when you have to. So, what's the slope of P?
Majority of mine.
2/3. Now, is it positive? Let's make sure we don't need to put a negative on it. As X is getting bigger, is P going up, or down, down? Up. So we're good. It's positive. All right, now let's find the slope of Q. Oh, sorry, N. I thought it was P and Q. I just assumed it was P and Q. N. Find the slope of N. Use the other 2 dots that we did not use last time. Betty, did you get a slope? Almost.
No.
Our other one was 2/3. Let's see, we fall how many? 1, 2, 3, 4, 5, 6. Fall 6 and run 9. Now we fell, we went down, so it's going to be negative, right? We already know what 6/9 reduces to. What does it reduce to? 2/3, but this time it's negative. So our slope of N is negative 2/3. So Betty said it was the same thing, and she was really close. It was almost the same thing, except P is going up. It's positive. It has a happy outlook on life. And N is going down. N is negative. It's bad. Down. Yes, ma'am. We are going to learn that on Tuesday after your long weekend. We'll learn that. And these are actually not opposite reciprocals because they're 2/3 and negative 2/3. They're just opposites. But we'll learn about opposite reciprocals on Tuesday. And those will be perpendicular. These are not perpendicular. We're just trying to get ahead of ourselves. Okay. So, that was the counting method. We are all good at counting. Way to count. Good job. Now we're going to do the formula method with numbers, plugging numbers in. The formula method says to find the slope between 2 points, you need to do delta y over delta x. So I want you to do exactly what we did with our other ones, with our midpoint and distance. Circle the x's and underline the y's, please. Circle the x's and underline the y's. So laborious, isn't it, Jacob? Okay. To find the slope, we're going to find the change in y and the change in x. I'm going to show you 2 different ways to do this. You're going to pick whichever way you like better. Okay? One of the ways is just, which ones are your y's? The circles or the underlines? The underlines. So I'm going to do 2, which is underlined, minus, what's my other underline? Negative 6, over, what's my circle? I started with 2, so I better start with 7, minus 5. 2 minus negative 6, what is that? It's 8. And what's 7 minus 5? 2. Can I write my slope like that? No. What is 8 divided by 2? 4. What's my slope? 4. The answer is 4. Now let me show you a different way because this is easy to mess up.
Yep.
Sometimes you'll forget and you'll put x on top. Sometimes you'll forget your minus. That is easy to mess up. So another way that I recommend that you try when you're given 2 points is to make, I know you think it's a lot of extra effort, but it's really not. If you make yourself a tiny little table and you just put the points in, 5, negative 6, and 7, 2, then just find your delta x and your delta y like we did with table building. Find your delta x and your delta y, and that might be an easier way to look at it. 2 minus negative 6, you subtract them, you're going to get 8. 7 minus 5, you're going to get 2. And then, to find your slope, it's just delta y over delta x, 8 over 2. So it's up to you whether the table makes more sense or the formula makes more sense. You can do it either way. Let's try another one. Try this one. Number 5. You can do it the formula way, which is right here. This is the formula. Or you can do it the table way by finding delta y and delta x. I'll set up the table if you want to do it that way. There's a lot of negatives in this problem, so be careful. Lots of negatives. Be careful. Circle, circle, underline, underline. Negative 8 minus negative 6. Whew.
So from 6 to 8, how do you get from 6 to 8?
Right, so you would say,
2.
how would I get from negative 6 to negative 8? It'd be backwards 2. Okay. How would I get from negative 1 to negative 5? Backwards 4. Right?
Is negative 4?
Delta x is negative 4. Because look, if you have negative $1, to get to negative $5, you're going backwards. You're going to be negative even more. You're going to be more negative.
It's y over x. So.
Delta y.
Okay.
Delta y over delta x. Claire, what'd you get for your final answer? Almost. The delta y is negative and the delta x is negative. So when you have two negatives, they cancel. So what's your answer? 1/2. The slope is exactly 1/2. Maybe? Yes, no, maybe so?
Yep.
Try 4 and 6. Do the table way or the formula way, whichever one you're better at. Good question. You want to change what happened from 7 to 8. That's 4 minus 7, and it's negative 1 minus 7. Always the second one minus the first, every time. Yes, you may. I have plenty of those. So number 4, let's see. Delta y, 4 minus 7, and delta x, negative 1 minus negative 3. So what was delta y, everybody? What'd you get for delta y on number 4? Negative 3. What'd you get for delta x? 2. Good job. Look, there's our answer. It's already done. Negative 3/2. You could also write negative 1.5 if you really wanted to, but I like slope as a fraction better than a decimal, because slope means rise over run. I like it to be a number over a number, okay? I like this answer better, but I would not count negative 1.5 wrong. I would not count it wrong. Okay, last one, do number 6. If you haven't already done it, that one's easy. Number 6, are you looking at that? Did you try it? 0 minus 4 over 4 minus 0. There's no negatives to contend with. What is delta y?
4.
Negative 4. What is delta x? You have $4 and you take away nothing. You have $4. What's the answer? Negative 1. The slope on number 4 is -1. That is the answer, -1. -1. Let's move on. I think we've done enough. 4 of those is plenty to do, right? All right, so we talked about this in the warm-up. The larger the slope, the steeper the line. The smaller the slope, the flatter the line, okay? So I want to know which line is steeper. I give you 2 choices for number 7, and I gave you 2 choices for number 8. Just pick which line is steeper. See, it's on your notes. Number 7, write your answer. And then number 8, write your answer. Which one is steeper? You're just trying to figure out which one is larger, right? Because the larger it is, the steeper your line is. DJ, what'd you get on number 7? A or B? B. What is 9/4 in your calculator? 1.4. 1.4?
No, just 0.4.
Okay. No, 9 divided by 4.
It's
2.25?
no, I did that.
What's 7 divided by 3?
2.3.
Which one is bigger? 2.3 repeating or 2.25? This one's bigger, guys. That one is bigger. 2.3 is bigger than 2.2. So 7, the answer was A. And Jose, what'd you get for number 8? Okay, do it real quick. Remember, we don't care about the negatives for as far as steepness goes. Which one is steeper? A. Because 3.2 is a bigger number than 2.6, right? Okay. We're going to talk about a real-world problem really quick. This could happen in the real world. Have you ever done this or seen someone do this? You take a ladder and you put it against a building or your house and climb up the ladder to do some work on the gutters or to put up Christmas lights or something like that, right?
No, we
You've
climb.
seen a ladder leaning against the building before, right? Well, did you know that there's a safety issue there? If you put the foot of the ladder too far away from the building, the ladder could slide down, but if you put it too close to the building, it could fall backwards if you get too close. There's a certain amount of feet away where it's safe to put the bottom of the ladder. It's true. So, in this problem, it says to be safe, it needs to rest at a slope of 2.5. That's for it to not be too steep and not be too flat. We want the slope to be 2.5. So if the ladder touches the wall at 13 feet, so it's 13 feet above the ground, okay, so it's pretty high off the ground, not too high. How far away should they put the base of the ladder from the wall so that it's not too steep? Because, right, if you're in charge of this and you have contractors working under you and someone gets hurt on the job, what happens? What do? They sue you. And when someone sues you, that's a lot of money. So you want to make sure that the ladder is placed at a safe distance so that no one falls and no one gets hurt. Well, not just because of money, because you actually don't want them to get hurt, right? I mean, that too. So anyways, we want to know, we can measure with our measuring tape how far away to put the ladder. So how would we find the slope of that ladder? That's Pythagorean theorem. Very good. That's how long the ladder would be. But I don't care how long it is. I want to know the slope. What is slope? Delta y over delta x. Now, what is delta y? They actually gave it to us. You don't have to find it. What is the y? Is it this or this? Show me y. This. What's y? 13. So delta y is 13. What's delta x? Question mark. Delta x is question mark. What do we, that is the slope, right? That's m, that's the slope. What do we need the slope to equal? 2. Good. Does anyone know how to solve that? Yikes. We do divide or something. Well, we can't put a 1 here, because that's like our x.
13 divided by 2.
Ooh. Jessica said put 2.5 over 1. And now we cross multiply. Awesome thinking. 13 times 1 divided by 2.5. Just like Paige said, 13 divided by 2.5. This is math. That's what this is. So how far away should we put the ladder? 5 feet away. 5.2 feet away, and it will be as safe as possible and no one will get hurt.
Are we going to be cross multiplying now?
We'll do it more in the unit that comes after winter break. We'll cross multiply more. All right. So you can look at your other side or you cannot. We're about to graph some lines. So on the other side it does do the breakdown of what slope-intercept form looks like. But this is so old. You already know this. It's not exciting. But you've seen y equals mx plus b. What does m represent? The slope. What does b represent? The y-intercept. So when we say slope, when we say y-intercept, what is a y-intercept? Because we can say that all we want, but if we don't know what it is, then it's not going to mean anything. Savannah, what's a y-intercept?
It's when the y-intercept to the y-axis.
Awesome. So, Paige, where do you think, just eyeball it, where do you think that green line intersects the y-axis that I sketched on the board? Just give me a reasonable answer. What would be the y-intercept of that green line that I just sketched?
Say a number?
Yeah.
5.
Yeah, I agree. Don't you think it looks like about 5? As long as she didn't say like -10 or 32, right? I just wanted her to give me a reasonable answer. It's where the green line intersects the y-axis, not the x-axis, but the y-axis. Okay. So how do you graph a line? You know how to do this. You plot the y-intercept, like let's say it's 3, and then you just count the slope. If the slope is 2/3, you go up 2, over 3, up 2, over 3. And then you have a beautiful line, and you connect the dots, and that's how you graph a line. So let's try it. Look at number 10. Let's graph this line. You always start with the y-intercept. What do you start with? The y-intercept. So everyone go to the y-axis and find -5. Put a dot. I want to see your dots. Go to the y-axis and go to -5. 1, 2, 3, 4, 5. Put a dot on -5. Lillian, what's our slope? -2/3. Thank you for correcting yourself. So I want to go down 2 and then to the right 3. Down 2, 1, 2, 3, over 3. Down 2, over 3. Ooh, here's a question. From Unit 1, do you remember how many points it takes to define a line? I played a song about it. It takes 2, baby. Okay, anyways. It only takes 2 points. Did you know you only have to plot 2 points? I already did too much work. I plotted 3 points. You only have to plot 2 points, and then you connect it with a very straight line. If you can use the edge of your binder, it'd be wonderful. But if you don't, you can just make it as straight as possible. It only takes 2 points to make a straight line. All right, so the slope was -2/3, and the y-intercept was -5. That's easy. Yes, ma'am. Oh, yikes. You don't understand? Okay, let's do another one. And if it doesn't, oh, that's not a good one to do next. Okay, so -5 is the y-intercept. So we went to the y-axis and we went down 5. And we put a dot. That's your start. That's your starting point. Then we read the slope is -2/3. Negative means go down. So we went down 2 over 3. Down 2 over 3. That's how you do slope. Right? I didn't have to do it 2 times. I could have just done it 1 time. But it's still the same line. All the points lie on the line. I could have just done it 1 time. Alright, whoa, I'm losing you. I can't do this. Okay, so the next one says x equals -9. Which axis am I going to go to get a -9, the x or the y? Well, x is the one that equals -9. So go to the x-axis and go backwards 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot there. X is stuck at -9. It's going to be -9 for every single Y value. Good. The slope is undefined. So you need to stay at -9, and you want to grab all the values in the whole world that are at -9. You want all of them. So you make a solid line at -9, and that's what the graph looks like. Savannah said it, but what is the slope of that line? Can I make a Z out of it or a U out of it? A U.
The videos.
It is undefined. And what's the y-intercept?
It's undefined.
There is no y-intercept. The y-intercept is not 0. It's
It
not
isn't-
hitting
it
it at
isn't even
0.
crossing it.
It is never crossing it. So write none. The answer 0 would be wrong. The answer is none. There is no y-intercept. All right, we're almost done. What's the slope of that line? We've already done this. Negative, is it 1? No. Down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's going on? Do we have different pictures?
-1 over 4.
Oh, okay. Down 2 over 10. Math, enter. Good job, girl. What's the slope of that line, guys?
1/5.
-1/5. Oh, you were still talking. I thought you just said -1. You were saying -1/5. Okay. Here's your exit ticket. Get out your warm-up. Complete the exit ticket. I told you we were going to have one today. Calculate the slope of Kyle Field. Delta y over delta x. When you get your worksheet, when you solve this, you're going to get your worksheet. When you get your worksheet, I only want you to do the evens. What does that mean? 2, 4, 6, 8. Oh my goodness. Delta y over delta x. Yes, we did it 4 times today.
No, not like this though.
Just because the numbers are bigger doesn't mean your calculator can't handle them. I'm ready when you are. Show me your answer. On your exit ticket, on your warm-up sheet, I'll trade you. Page. Delta y over delta x. Delta y over delta x. Just trying to make y'all successful.
Thank you.
First one.
As long as she paused. Was that homework or no?
Yeah, well, delta y, okay. Circle your x's and underline your y's.
Is it 3/5?
Yeah, well, we're not going to yell any answers out. 0 minus 120 and 50 minus 250. Or you could do it the other way if you want to be positive. Do the evens, do the evens, do the evens, do the evens. Oh, was that last night? Why did that you yesterday? Thank you. Okay, so if you did last night's homework, it goes in a tray, and we'll talk about it tomorrow because I forgot to talk about it. If you didn't do last night's homework, you can do it tonight. And here's your slope practice. You're only doing the evens. It should only take you literally 5 minutes. If you're only doing the evens, it should not take you longer than 5 minutes.
Well, I got 100.
It is.
This one.
I think it was 3/5. 3/5.
That's 120.
What answer is
Maybe not. minus 120, and then it was 50 minus 250. So it's 120 over 200. 120 over 200. 0.6. Math.
That's what I got.
Enter, enter. 3/5.
Oh, he was right. Okay, here you go, man.
Only the evens. It should be a very short assignment. No excuses if you don't finish this. Because I'm cutting it in half for you. It's already a half sheet, and then I'm cutting in half. Cutting in half your half sheet. You have last night's homework? Put it in the tray.
Can I take this for homework or what?
Start doing it right now.
Because my parents are like, why don't you have one?
Here you go. Here you go. We don't have a quiz tomorrow. Our quiz over this stuff is Friday. Over your tables, which was your homework. That quiz is Friday. So you have to do that homework tonight if you didn't do it last night. The table building homework that looks like this. This is the one we're talking about. You're going to do that tonight if you didn't do it last night. Because you have a quiz over that on Friday. I'm not going to make it late tomorrow. You can turn it in today or tomorrow because even I forgot about it. But if you already did it, then you're home free. So right now you're working on the evens. Until the bell rings, you're working on the evens. You still have like 3 minutes, so you might as well keep working. 5 minus 3 is 2. So it's delta y. So it's delta x. Just make sure you're putting the y's over there.
What do you mean?
So it's probably good. It's probably right. 5 minus 3 is 2. 5
Yeah.
minus 1 is 3. I don't think any of them are negative. Because look, that's a big number minus the small one and a big one minus the small one. So you're positive 2/3. Jose's almost done. Almost done.
Well, good for him.
See what can happen when you get started right away instead of goofing off and making jokes
for
and
you,
walking
Jose.
around the room and procrastinating. You could be done by now. You could be done. You could be Jose right now.
I don't
You
want
could
to be
done.
Jose.
If you would have started right away, you could already be packing up. Shame on you. Talking to everyone except
Hey, you
Jose.
trying to put all of us on blast or what?
For real.
I'm trying to light a fire under you so that you
That's
work,
the same thing.
so that you work harder.
That's the same thing.
Raise your standards. 2, 4, 6, 8, 10.
I'm gonna do all of them.
Jose and Trent are done.
Well, I have 1 point to run.
2, 4, 6, 8, 10.
2, 4.
Yeah, that was going to be on the test, so that's why we
I
didn't
thought
put it on there.
I showed you.
Do those. Oh, were you doing them all on the calculator?
Yeah. It was fine. But I'm pretty sure it's fine for 8.
1.5. 2.5, 3.5. So when delta y doesn't work, you do delta y, right? It's 1, 1, 1. Now, then you do the 2 squared, which says take that number and divide it by 2. Remember that? Yeah, because you did it right here. So actually the coefficient is weird. It says it's a fraction. 1/2. 1 divided by 2. So you do 1/2 times 1 squared. How do you make 1/2 look like 3.5? Where you just add 1/2 times 2 squared. So plus 3 is 3 squared I'll take your slope if you're done with slope. Oh, then take it. Yeah, finish it. Oh, we're not singing. Awesome. Good job, Jose. Thank you, ma'am. Oh, wait, let me take your
I did.
You did.
That was a pretty short worksheet.
It was.
So Savannah, did you finish it? Did you swap off?
Sorry.
You did it? Shame on you.
She was finishing up her homework. Did you turn in your homework? See.
Some got it, okay?
My algebra teacher told me specifically to my date last year. It says perfectly clear.
And then parallel is when it's the same
state.
Stop. Just stop. Getting on to yourself about it. It's been a whole year.
Parallel is the same slope.
But like, I almost made that mistake on the EOC too. I was like,
Oh, I'm gonna take the one EOC this year.
Right, each problem was worth 10 points. Because you rounded wrong on number 1, so it was -1. You got -10 and -1, that's -11.
oh, yeah.
You rounded wrong on number 1, and you got number 2 wrong.
How I rounded.
How did you round wrong? Oh, it said round to the nearest tenth. That's 1 decimal place. You put 2 decimal places, okay?
yeah.
Okay. But instead of counting it wrong, I only counted 1 point off for rounding. So out of all 10 points, you only got 1 off for rounding.
Is my grade for 6 weeks good?
Oh, I'm not a walking grade book. I don't remember. It was whatever I showed you last week. It didn't change from last week. Yeah, I didn't take any new grades.
Oh, okay.
Okay.